Hi, I'm Professor Goins. In this video, I'm going to discuss the concept of the conjugate for both square roots and then for cube roots, and show you then even how to generalize from there. Okay, the conjugate of the expression 1 minus the square root of x minus 3 is 1 plus the square root of x minus 3. So notice these two expressions here, the only thing that changed was the sign that's in between. Because the reason it's a conjugate is when I multiply these two together, so if I FOIL it, notice that the two middle terms will cancel, so I've got a plus with a radical, minus with a radical, so those two would cancel out, and then I've got a square of a square root, so that cancels the radical, and I get 1 minus x minus 3, which is 4 minus x. So the idea of a conjugate is it's an expression that I multiply by to eliminate the radical. And this will be useful in your calculus course. When you do certain things with limits and derivatives, you can watch other videos to see what those are all about. But it's an expression that I multiply by in order to eliminate a radical. And you'll probably even use it within pre-calc as well in a few places. But again, generally it's used in calculus quite a bit more. But at any rate, if I want to generalize this to, say, cube roots, then we have to dig a little bit deeper into why this is the conjugate. Because if this was a cube root and I just changed the sign, it's not going to work. So we have to figure out, so this is just illustrating why those are conjugates, but where does it come from? And in order to find that, I'm going to remind you of the factorization formula for the difference of squares. So if I have the difference of perfect squares, it's the difference of the bases times the sum of the bases. And what I want to do is let's take a look at this expression right here, or that equation, and let's match that up to, let me take this first part and then this last part. Notice that, actually, well, we could do it right here. And I'm going to take this information with those deleted and put it up on this line. So this is the same thing as 1 minus this. And so look at this line right here and look at this line right here. Notice I've got a difference of squares, I've got a difference of the bases and the sum of the bases. So the idea is this is what we started with. Meaning, if I was to match that up over here, I have this. So I have an expression, and I want to multiply it by something to eliminate, if I have a radical here, let's say it was a square root, I'd want to be able to square it. I'd want to be able to square that square root, so I want to be able to put a square on it. In order to do that, I have to multiply by a plus b. And that, again, comes from this factorization formula. So let's say if I have, so let's find a conjugate, but let's, rather than just saying let's just switch the signs, let's figure out what it would be using this, because that will then help us to generalize for other radicals. Let's say I have the following conjugate, or the following expression. I've got x plus the square root of x plus 1. Okay? And what I want to do is I want to multiply it by something so that I want to be able to square this, right? In order to square this, I'll have the square root of x plus 1 squared. And let's match this up right here with what I have on the top. So this would be a minus, this would be the square of the first factor, so it would be x squared. So to square both of those, in particular to square the radical, we have to put something here. And if I've got an x plus a radical, that would be a plus b. I have to have a minus b, meaning x minus the square root of x plus 1. Multiply by that, and you're going to get this, which is going to then eliminate the square root. Okay? So now, what could I do if I have the following? What if I have the cube root of x plus 8 minus 2. Well, I want to be able to multiply by something so that I can take this and eliminate the radical by taking it to the third power. And then I have a minus 2. That would also end up being to the third power as well. So how do I multiply by something to eliminate this radical? Well, the procedure is going to be virtually the same or analogous to what we did up here with a difference of squares. So recall, if I want to think of this over here as like a to the third minus b to the third, how does that factor? So a cubed minus b cubed is a minus b, so it's the difference of the bases. Notice here I've got a difference of the bases. And then it's multiplied by the quadratic a squared plus ab plus b squared. So in order to take, if this a is your cube root, if I want to cube it, I have to multiply by this expression right here. So this would actually, this is the key to finding the conjugate for a cube root, where the cube root of x plus 8 is a and 2 is b. So this is cube root of x plus 8 would be your a, and 2 would be your b. So let's then construct the conjugate, and then we'll multiply those together to make sure that it all works out the way we expect it to. All right, so in this case, if this is a and this is b, then the conjugate, so let's just write what the conjugate is first. I'll abbreviate it as c, would be the square of a, so that's the cube root of x plus 8 squared, plus the product of a and b, so that'd be 2 times the cube root of x plus 8 plus b squared. So b is 2, so that'd be plus 4. So for this expression right here that I started with, remember I said don't just switch the signs, make that a plus. This is what the conjugate is. And it comes from the difference of cubes factorization formula. All right, so let me clean up the whiteboard, and what I'm going to do is I'm going to multiply this expression here with this expression here to verify that we do eliminate the radical. All right, here we go. So I've got cube root x plus 8 minus 2, and I'm going to multiply by cube root of x plus 8 squared plus 2 times the cube root of x plus 8 plus 4. Make those parentheses a little bigger to distinguish between those. Okay. So when I distribute, when I multiply together 2 terms to 3 terms, remember I'm going to take this first term here and distribute that to all 3 terms. And then I will distribute the negative 2 to all 3 terms. So giving me a total of 6 terms. Okay, so here we go. So when I distribute the cube root through, we're going to get cube root times the square of the cube root will be a cube of a cube root. So cube, but let's not eliminate that yet. Let's show all the details. So that'd be the first red arrow. Then the second red arrow, I would have plus 2 cube root x plus 8 squared. And then I would have 4 times the cube root. So the 3 terms that I just had there, just wrote, would be each of those 3 red arrows, so all 3 of those multiplications. So now let's distribute the negative 2. Okay. These 3 terms here are the 3 green arrows distributing the negative 2 to those 3 terms. All right, now let's see what cancellations we have. Okay, so twice the square of a cube root minus 2 times the square of the cube root. So that term and that term go away. And then I've got plus 4 times a cube root minus 4 times a cube root. That and that go away. And then I have the cube of a cube root leaves with just an x plus 8. Then I have a minus 8, leaving x. So we did eliminate the radical. Okay. So again, for a cube root, you have to use the difference of cubes factorization formula. So let me just show you how you would do it in the case of a 4th root. I'm not going to go through all the details on the board, but I'll give you an idea. Maybe in a later video, if there's any requests to do it, I can work out the details for it. But let's say, for example, I had a 4th root of x plus 1 minus 1. I want to find the conjugate of this. All right, so my motivation is going to be here for the a conjugate for a cube root, we use difference of cubes. Conjugate for a square root, we use difference of squares. Therefore, the conjugate for a 4th root, we are going to use the difference of 4th powers. So let's see how that would work. So I've got a to the 4th minus b to the 4th. Well, this is the difference of squares. So it's a squared minus b squared times a squared plus b squared. Here's another difference of squares. So you've got a minus b, a plus b, a squared plus b squared. Okay, so this right here is going to be the key. I have a difference of 2 terms here. So this is a 4th root. That's sort of like your a minus b. So in order to put this is a 4th root, in order to put a 4th power on it, then I have to multiply by this expression right here, where a is your 4th root of x plus 1, and b is your 1. And multiply all those together, and you'll get a 4th power on those to eliminate the 4th radical, or the 4th root. So whatever the index of the radical is, 2, 3, 4, 5, 6, 7, 8, whatever the case may be, in order to construct your conjugate, you're going to use the factorization formula for the difference of this power here would match the index.